Hello, my name is Clive Scott, and this is part 17 of a course on Java, and it's called A Second Look at Classes. And I'm covering things like access, overriding, and hiding, and quite a few other things. So this one's quite long. Okay, this is the contents of what we're going to cover. What we're going to do, including things like multiple inheritance. Why that's a problem for some languages, and how Java avoids that problem. All of these things down here are connected in some way or other to overriding. We've also covered things like access qualifiers, including this one, protected access, which a lot of people get wrong because it's quite subtle. What else? So I'll also give some sort of very crude view of the virtual machine, so you get some idea of how that handles overriding. And we see implicit interface members. That's something which isn't really covered very well by a lot of books. They don't even mention it, some of them. Finally, I'll just give a quick preview of overloading. I was going to include that in this lecture here, but it would have pushed the time up too long there. As it stands at the moment, this thing looks like it's going to run over 2 hours. So I've just given a quick preview there, and we'll cover it properly in the next lecture. The first thing to talk about is abstract classes, and so the question is, what's an abstract class? Well, the thing about an abstract class is just like an ordinary class, except you don't have to fill in the body for every single method, and you can leave it to subclasses of that class to fill in the bodies. What we actually mean is implement it, just like in an interface. And in fact, these are a bit like an interface, except you can have real methods in there, perfectly ordinary methods, as well as what's called abstract methods. And that's what an abstract class is. And the important thing about an abstract class is that you can't instantiate it. That means you can't do new on it to get a new object from it. And it has to be marked as abstract by preceding it with this keyword abstract. And any method in the class as well if it's not got a body, it's got to be preceded with the keyword abstract. Okay, so what's it used for? Well, here's an example. Supposing you've got a program for drawing shapes, and supposing it can draw circles, rectangles, triangles, whatever, and if you think about that, if you have a class for each type of shape that gets drawn, then some of the behavior is going to be common to all types of shape. For example, they're all going to have a draw method to draw themselves, and perhaps a resize as well, whatever. I mean, you can imagine things. And some of the state information is going to be common as well to all the shapes. For example, they're all going to have say a color, the color in which to draw the shape, and maybe something like line thickness and the style of line and that sort of thing. All the classes are going to have that as a field. And of course, some of the things are going to be specific to each shape. Only circles will have a radius field, for example. And all this is a good candidate for what's called an abstract class called shape. So we have it up here, and we inherit, all of them inherit from this class. Okay, and I'll just show you what that looks like in programming terms. Well, this is what it looks like in programming terms. Got this class shape here, and that's an abstract class. You've got to have this word abstract in front, and it's an abstract class because it's got this abstract method in it, and that looks just as if it had come out of an interface. So there's no sort of body there, it just ends in a semicolon, and it's got to have the word abstract in front now. These are just ordinary methods, and that's just as you'd expect, just perfectly normal looking class. Apart from that, have this as a both abstract. Okay, this is class circle and rectangle and triangle and whatever else I'd thought of. That will also look pretty similar to this. You have a class for that, an extends shape, and it's got to have a draw shape in it corresponding to that abstract method. And there's just a constructor. Okay, so that's what they're all going to look like, and this is where it starts to pay dividends. Shape, of course, is just an ordinary class apart from being abstract, so you can certainly define an array of it, and here I'm putting some stuff into that array. New circle, new, I don't know, triangle, I don't know, use your imagination. And here I'm going through the class using the array using the enhanced for loop, and printing out, drawing each of the shapes in there. And you'll notice that I've not had to refer to what class that S happens to be. I haven't got to. Now, where have I said is S instance of circle, then draw this or whatever? It works independent of that. And this type of behavior is called polymorphism. And polymorphism is from a sort of Greek word, and it means many forms. And what this really boils down to is basically a method, in this case draw shape, can do different things based on the class of the object. So in this case the class of the object is determined by S, whatever S happens to be. So if S is a circle, it will call this version of draw shape. If it's a triangle or something, it will call the draw shape that's in the class triangle. And you can think of this it's behaving sort of like it would do if shape was an interface, really. It's just resorting to whatever class S happens to, whatever class S happens to refer to, it's that version that gets called by draw shape. Now, one of the big advantages of this, of course, is that you can extend this very easily, this mechanism. So supposing you've got something like ellipse, say, and you want to draw ellipses everywhere. All you have to do is create a class ellipse and extend shape and put a draw method in a constructor, and you're away. There's nothing else you have to change. This all doesn't change at all, this bit of code here, and that's one of the advantages of polymorphism.